So, welcome everyone to our webinar today, where we from Blues are co-presenting with our friends once again from Edge Impulse. Happy to have you guys here again. So today our topic is, as the title says right here, anomaly detection anywhere. Now, what this refers to is actually pretty astounding to me, as we're going to combine some pretty advanced but still quite accessible Edge AI concepts with some equally advanced but frankly equally as accessible satellite connectivity techniques. And bringing us to this term that I honestly thought I had made up, but it turns out, of course, others have said this, that being Edge AIoT. I thought that was kind of cute. But for years now, really, I've heard and definitely repeated that for IoT to be truly successful, it must embrace TinyML, which we now refer to as Edge AI. And of course, who better to help Blues on this journey than Edge Impulse, who, if you did not know, was recently acquired by Qualcomm. So completely validating their direction here. So congrats to you guys. Congrats to Edge Impulse on that. Before we really
Absolutely.
start, if you have any questions at all during the presentation today, of course, ask those in the chat panel or in the Q&A panel. Either are fine. We're going to actively answer the questions as they come up, since there's, of course, four of us here. Whoever's not speaking can answer questions. If we have time at the end, we'll do more of a public Q&A with some of the best questions. But we'll have to wait and see. Question we always get, I always have to say this, is it being recorded? Of course, it's always being recorded. It'll be available on the Blues YouTube channel at this URL. Feel free to subscribe there if you so desire. Now let's do some quick introductions, starting with the Honorable David Tischler, who is a program manager at Edge Impulse.
Honorable. Wow. Thank you, Rob.
Thought I'd throw that in there. From Edge Impulse, we also have the esteemed DevRel engineer, Owen Jordan. And lastly, from Blues, we have TJ Van Tol, our principal developer advocate, and myself, Rob Lauer. So thanks again, everyone, for being here. So let me kick things off by kind of breaking down our topic today, sort of at a high level, because I want to start with how we're addressing this part of the topic. And the first part being, of course, Edge AI. And today that begins with gathering diagnostic data from something, right? And today that something are the readings from a vehicle's OBD port. Think of like coolant temperatures, transmission temperatures, fuel economy, fault codes, anything like that, and actively checking that data for anomalies. Anomalies that may not be easily detected just by looking at min-max or specific values, right? And when building an Edge AI model based on that data, oftentimes you're weighing the complexity of your model versus the hardware it's running on. Now, today we are admittedly cheating a little bit and using a Raspberry Pi, but in many, many cases, you're talking about highly constrained microcontrollers, which brings us to the solution of this problem, of course, that being Edge Impulse, which in many ways I believe is the easy button for Edge AI, right? I say that because I can train, test, deploy on anything from a tiny MCU up through a Pi onto a Jetson and so on. So we'll see this kind of play out today. The second part, again, at a high level of the anywhere side, what does this even mean? Well, the second part of our story is all about wireless connectivity, because that data, those Edge AI inferences, are really only valuable when you get them somewhere, right? And literally anywhere you are in the world, there's going to be some types of constraints in your connectivity, especially when you talk about communicating with moving vehicles, right? Then you have different cellular protocols to deal with depending where you are, tower handoffs, poor reception, so on. We've all experienced this. Plus, in many scenarios with something moving, you're wanting to track location. GPS is fantastic, but of course, it can be sensitive to visibility of satellites, is really power hungry. Well, like Edge Impulse is for Edge AI, I will claim that Blues is the easy button for wireless connectivity, especially as it pertains to cellular and its seamless fallback to satellite, which again, we'll see play out today. Now, I don't want to spoil anything from our other speakers, but I did want to show off how kind of the high level overview of how the demos are going to work today, and how one might use a device like this ELM or ELM 327 to read data from really any vehicle's standard OBD port. We're going to be streaming this data into Edge Impulse Studio to create a robust anomaly detection model. It's going to tell us if anything looks off with any diagnostic readings from the vehicle while it's in use. And if and when anomalies are detected, maybe we want to periodically just sync readings from the device to the cloud. We're going to send those to the cloud over cellular. But again, anyone who's gone anywhere on this planet knows that cellular connectivity is not yet ubiquitous. Therefore, there are going to be certain critical times, maybe critical diagnostic errors, where we need that data no matter what. And that's really where satellite connectivity plays into this anywhere theme. And I do want to caution you ahead of time that yes, it is very difficult, if not impossible, to demo satellite connectivity from indoors. We're going to do our best today. I will actually be the one to attempt some satellite communications via an antenna that stretches out through my window next to me, but more on that towards the end. So to translate everything I threw at you into kind of a loose agenda for today, we're going to start with a quick intro to Edge Impulse from David. We're going to show you how the Edge AI model was built. Owen's going to show that off. And then TJ is going to deploy said project, said model on a Pi for a quick demo. And then I'm going to come back to kind of round things off to explain satellite connectivity and how it works with Blues. With that, I'm going to hand things off to David. Feel free to take it away.
All right, let's see if I can figure out how to share my screen now. I see I have the border around it, but you know what? We might just go with that. I'm a little bit afraid to make any changes, and I'm laughing, Rob. It wouldn't be a live stream, a live webinar if a demo didn't have some issues. So if that antenna out your window doesn't quite work out, I wouldn't be too terribly surprised. That's part of the fun, really. Um, but thank you for the intro, Rob. We've done a couple of webinars in the past, so some of you folks may certainly already be familiar with Edge Impulse, but I did see quite a few names on our registration today, and I think that might be because I think this is the first time we've touched on automotive as a use case. We've certainly done predictive maintenance in the past and industrial and anomaly detection, but I think this might be our first go at fleet management, not fleet management of devices, but fleet management and fleet monitoring in the automotive landscape. So welcome to all the new faces. So, as Rob said, I'm David. I'm a developer advocate, sometimes referred to as a program manager as well. Depends on where you're looking here at Edge Impulse. And for anyone who is not familiar, Edge Impulse is a platform to help you create custom AI models. And what do I mean by that? If you are not already I don't want to say up to speed, but kind of living and breathing edge AI on a daily basis. And if you're coming more from a general AI perspective, you might be thinking LLMs, those are obviously the popular implementation, even VLMs for that matter, image generation and things like that. What we focus on, though, is creation of custom models. And so there are lots of model zoos already out there. NVIDIA has a wonderful model zoo that can do object detection on common objects like a person or a cat or a dog or a banana. But if you need to do detection, classification, or in the audio world, keyword spotting, audio classification, and as we're going to see in today's demo, sensor ingestion. There's no off-the-shelf models that exist for that. You're not going to be able to go to Hugging Face and find a model that, let's just use this valve as an example. If this is the product that you are building, this exact valve, there's not really anything out there that is going to be able to identify, detect this particular component. And so when you need to train something unique, that's what Edge Impulse helps you to do. As I said, we allow for sensor data. That's helpful for pattern recognition or anomaly detection. Audio data, wake word and keyword spotting or sound classification, audio classification, and image data. And that's the more traditional things like we were just talking about, object detection or image classification. We go across a wide variety of hardware, all the way from the lower end of the spectrum to the larger big GPUs and other machines and everything in between, MCUs, NPUs, MPUs, CPUs, you name it, it's supported in the ecosystem. Rob, you mentioned, earlier this year we were acquired by Qualcomm, so we certainly enable Qualcomm hardware now as well, but our entire ecosystem is still supported. So all the other targets, I mean, Owen's about to use a Raspberry Pi and it will work just fine. And for those who are building their first model, I like this kind of visualization that keeps it very simple. Owen's going to dive deeper into these steps, but in order to build an Edge AI model using Edge Impulse, really it's four simple steps. You need to collect your data. You'll use that data to then build what we call an impulse, which is the pipeline, and that's the essentially the training of your algorithm of your model. Obviously, you're going to want to test your model. Um, Owen's going to show how to go through that as well. And then finally is deployment when you're ready to put it onto a device. And that could be one device or at scale, many devices. Um, we'll go through the studio in a bit, but just to kind of show you what it looks like in practice, again, data set collection. So in this project here, I was taking pictures. I wanted to identify these little miniature blocks. Rob, I know that these are your favorite. Uh, Mine, however, are unlabeled. I don't have the Edge Impulse logo on mine like you've got the Blues logo on yours. But in this project, I wanted to be able to identify these little blocks as they came down the conveyor belt. So took pictures of them from the camera rig. We'll go through the creation of the impulse itself, a selected object detection here, and ran a training run. This is not specifically to brag that I came away with 100%. It's probably a bit unrealistic because it was a small sample size, but I just wanted to show and demonstrate that you come away with some metadata at the end that shows you the performance of your model. And then you choose a deployment target. On this particular project, I happen to be using an Arduino Nicla Vision. Again, another great board from the team over at Arduino. Um, but it's pretty much as simple as that. I think that's actually going to do it for me. I wasn't keeping track of the time, but I might have made that in under 5 minutes for you, Rob.
Perfect.
All right, let me stop sharing. And are we passing over to TJ
To
or are
Owen,
we
I
going
think.
straight to Owen?
Straight to Owen.
Okay.
Oh, and you're on mute.
Okay, I'll unmute. Okay, you can hopefully hear me now. Thanks.
Yeah, you're good.
All right. Yeah, thanks, Dave, for setting the stage. So I want to show what we can do when we run out of scenarios where we've got available sensors on a dev board, or if you want to stream data or use data from an industrial machine or an automotive machine, and what we use to do that and how we can access different sensor data. So I just want to skip on here. So OBD, so we'll figure out like what kind of problem we're trying to solve. So for, let's say, an automotive issue that we can create a healthy and an unhealthy condition, something that we can classify. We want to, I've created a data set here with a sample, which is an air leak, which is associated with a specific troubleshooting code that you can scan with your OBD scanner. For anyone who's worked on automotives or had an engine light appear on their car, then that's mapped to one of these codes. And that code can then become our label for our data for our unhealthy condition that we want to predict in future. So air leak, I wanted to pick something that would like either lead to something that would be dangerous or lead to something that would be costly. And an air leak in this scenario is going to be costly for repairs. So at the intake of your engine, you've got one sensor, which is your mass airflow sensor. that measures the air that comes into your engine. Then you've got your engine, which adjusts its RPM according to your throttle. You can record that as another sensor value. And then on your exhaust, you've got your NOx sensor, which gives you a larger amount of burnt fuel, and it can cause damage to the catalytic converter during this process. So when we're building a model, and this one is a sensor fusion model. For anyone who's worked with Edge Impulse before, we've got a number of sensors, and we know what we want to classify, and we know what sensors are important. So they're the ones that we're going to capture. A car or a vehicle or a truck in this case has many onboard sensors that we can tap into and request and record them as a CSV for later processing or stream it to a MCU. So OBD-II runs on CAN bus. So we've got pins on our OBD port that we can tap into directly, or we can use a Bluetooth scanner, or you can use there are many of these different devices that you can get access to your OBD port. And I wanted to mention CAN bus as well, because you can use this for industrial machines as well. I know we spoke about PLCs before, and we looked at industrial data. And many times we've got these large CSVs that are created in industrial data sets that we want to work with. So now we've got our condition or our problem that we want to solve, and we've got our source for our data. So the next one is a library to be able to get access to that data. And Python OBD, thankfully, has a library that we can use to access it. There's also many Android applications that you can use if you've got a Bluetooth OBD dongle that you want to connect into your car or your truck or your tractor or whatever you want to pull sensor data from. And that standard is out since 1994, so you can really retrofit your old fleet. It's like when we speak about brownfield implementations of things, I don't know if there'd be too many trucks that are still operating that are older than 94, for example. So we're going to grab our data then and record it as a CSV. And for this session, that's where it'll kind of end. We're going to play that CSV back to the Linux runner, which is our Edge Impulse operator that's going to bring in our model and give us the classification result, and then that'll pass it on to Blues. So here we've got the data that we're capturing, and we've got the label that we can associate with what we're capturing, which is our healthy condition here. So you could record if you've got, if you've got a healthy condition, for all you need to do is record, let's say when your truck or your car is working in an optimal condition, record that for a while. Then you've got the sensors that you wanted to predict on for the healthy condition. Then once the DTC or the driver troubleshooting code is thrown, you can use that then to replace for your label. And then we can upload that to our Edge Impulse project for our healthy and our unhealthy condition. We can see here visually that the NOx values for the unhealthy condition start to rise relative to the RPM. And this is, if you notice a scenario like this with your industrial machine or with your automotive vehicle, then you can start to predict that in future. So we're just mapping previously known data with future outcomes that we want to predict. And it's not just limited to classification either. We can do regression as well, where we want to do numeric prediction, or if we want to look at sensor drift, or if we want to really get into the prediction of failure of parts or sensors themselves. So just to kind of recap on that, we've got our OBD port that we can access through our Pi or our MCU. We can then stream that data, or even mobile, capture that data, map it to our DTC codes, our driver troubleshooting codes for our unhealthy condition. There we've got our CSV that's been created, and now we can upload it to a project with Edge Impulse. We can create our project. So let me just give a really quick view of our project now. So Here is our healthy condition. You can see that the RPM is changing and the NOx isn't. And then if we go to the very end, we've got our unhealthy condition, our air leak. And when you're creating a project or a impulse with edge impulse, you can just go with the default values for this. I didn't change anything here. I went with added my spectral analysis block. And if you've got many different sensor values, you can just use the ones that map to your condition. Then you can add your classification block and the spectral features then for your air leak or your fault and your healthy condition are what you'll save. And that's it. Then you go through, train your project, and then we'll get onto the deployment where we can work with the classification for our sensor values. I can pass on to TJ then to show that in operation.
Sounds good. I think Rob was going to give a quick blues intro to lead in. And Rob, you're on mute now.
Unmute myself. A question just came through in chat. How do we deal with rare and unbalanced events in anomalous detections since some rare events might occur? Thought that was kind of an interesting one.
Oh yeah, that's a great one. So that anomaly detection, we could just add it. I can just show here right now. If I share my screen again. So here we've got our classifier that we've added. We can just add different learn blocks here. So we could add a anomaly detection one for k-means. So if we've got clusters of data, so something that's slightly outside of our condition. So like a sensor starts to break down, or if we've got a slow air leak, something that mightn't throw an error code, we could maybe have something that was close to becoming an error that we'd add in with our anomaly detection.
Cool.
So a related one that just came in is the plan to predict if a future reading would be healthy or leak, or to classify in real time.
Yeah, that's the good question. So what we were
that is.
speaking, yeah, what we were speaking about here is if we wanted to build something, let's say an MCU with blues, and we'll have one of these CAN modules that we can connect directly into an OBD port for a specific condition. So we could have like many conditions if we had, let's say, a Linux device. If we just wanted to, say, create a predictor that would prevent some kind of something that could end in like a catastrophic failure or an expensive failure, then we could have that connected into the device. And then when the truck or the vehicle goes out of range of GSM, we can still get an alert out. But I don't want to go too far in that. We'll pass it back to Blues for going further.
With enough data, though, I bet you could start getting to a point where predictions could be made for future issues or problems that may potentially occur and bring a vehicle in advance of for maintenance.
Oh, for sure. Yeah. I looked at the likes of,
Mhm.
so previously I had also looked at audio event detection. So there's lots of these, like engine wear and different things that can end, in catastrophic failure as well.
Yeah.
That won't throw any kind of DTC code, but we wanted to look at things that we could try and work with from a sensor value.
Yeah.
Here.
We did limit this down because if anybody's looked at OBD data before, you know that there's just a mountain of data that comes in, which is very cool in a sense because there's a lot you can do with it. But we had to kind of limit the scope to keep this digestible for this because there's literally hundreds of things that you can work with.
Yeah. So I wanted to interject here before TJ started talking because I did, like David did for Edge Impulse, I want to do a quick overview of blues and the connectivity piece before TJ started using some terms you might not be familiar with. So we may have even said the word already, note card, but it is just so you know, the Blues' core hardware product. So what note card does is it enables wireless connectivity for your product, pretty much in summary. It's important to know it's not just a modem, though. It does contain the radio and components, circuitry, all that to make it function really as a standalone wireless connectivity module. So it's a lot more than just a modem. And what does it do? Well, I always like to frame it as occupying this boring space, right? This part of cloud enablement for your product that you don't want to deal with. You're good at building your product today, right? We're building our Edge AI model. We're deploying it on the device. Maybe you have a cloud integration. You probably have a cloud integration somewhere, whether it's sort of an IoT platform or maybe one of the big clouds, something like that, we at Blues provide that seamless bidirectional data flow between the two of those. And what gets people super excited about the Note card first is that our cellular Note card does provide global reach, ships prepaid with 500 megabytes of data, 10 years of service. There's no monthly SIM fees at all. Um, you can, yes, literally connect your product to your cloud with 2 lines of code. I'll show you some of this in a little bit. It is also built to be low power. So Note card itself only consumes 8 to 18 microamps when it's idle, depending on the type of Note card you're using. And the Note card uses Note carriers. These are effectively development boards or carrier boards that act as that interface between Note card and your chosen host. Now, I did say types, plural of Note card. There's plenty of Note card options depending on the radio that you want to use. The cool thing is they are all swappable, both in terms of the physical connector, so that M.2 connector at the bottom, and the fact that you literally use one API the same way to program all Note cards. So this does allow for mixed radios in the field with one set of firmware running your fleets, or you can swap in and out. So if you can start with Wi-Fi when you're developing locally, switch to LoRa or cellular or whatever when you're deploying in the field. Now, Note card at Blues is really only half the story, though. The other half is our cloud service we call Note Hub. Out of the box, Note card knows how to securely connect with Note Hub regardless of the radio that it's using. It'll also sync its data with Note Hub, and then you'll configure Note Hub to sync or to route that data to your cloud application. Again, whatever cloud app it might be. So again, really providing this easy to use bidirectional data transfers. If you haven't gone there yet, check out our developer guides at dev.blues.com. You'll get example apps there, the full API reference, data sheets, all that kind of stuff. So that's my ultra quick summary for Blues. So TJ, why don't you take it from there?
Yeah, so what I'm going to do is try to put everything together. So I will bring up my screen here. And what I have up is my Visual Studio Code environment, and I've got a Python script up here. So what I'm doing is I'm going to show you off a firmware example of what it looks like to put things together. Meaning, in this project, I have an edge impulse model. That's what this EIM file is in here. This is something Owen gave me. He trained it all in edge impulse. He took in the data. I plopped it in this Python project so that I can use it. And then the other thing I've got is some CSV files over here. Now you might have noticed, but I am not currently in a vehicle, in case that was not clear. We did briefly consider having one of us
Are you
in a
sure?
vehicle.
Are you sure,
this.
TJ? You sure you're
Yeah,
not in a vehicle?
exactly. So I did make one adjustment to the script versus what I'd normally deploy to say like a production environment for firmware. I am reading this data from a CSV file. So what Owen did is he created these two different CSV versions, one with his car operating as normal, and one where he created this sort of simulated leak scenario. So we had some data sets to work with. These CSV files have the data that we're interested in from the OBD ports that were used to train this model. And then the one bit of code, so I'm going to scroll quick to the bottom here because this firmware is essentially a big loop where I just pause a half second. So each time this script runs, it plucks a reading from the CSV file to mimic taking an OBD reading. And then it sleeps half second because that mimics the capture rate that Owen used when he actually built up these files. So we can pretend for a minute that I'm in my car here. I'm running when this script is going and I'm processing this data. Now, the key part of this, and this is code that is from Owen's documentation that we'll be sharing here at the end of this if you want to follow along. What I'm going to do is pluck out just a few important bits of this. The main thing I want to grab or show is this bit here. So the code above this is plucking the data out of the CSV file. It's formatting it up. The magic, the actual inferencing happens right here. This is where I actually send my data into the model itself, and I get back a result or a classification. And then I do some formatting with some code that was definitely just copied straight from the Edge Impulse documentation, leading to what is the most important line in this entire script, which is this right here. This is the condition that we care about, the whole reason at the moment that we're writing this firmware. In this condition, it means we've run our data from the OBD port, we've sent it through the model, and the label that's come back, the top label that the model classified this as, is that this is a leak. And the model also gives me back a probability. So I'm saying the probability of the leak is above 80%. So this is the scenario where there's a leak detected, and we want to take some action. Now, the cool thing about doing this at the edge is that we can take all sorts of different actions. We're in a vehicle. We could make a light pop up. This is more or less kind of how your engine service light works, right? It detects the error code, it pops up something. But with our approach, we could do something custom in the vehicle if it made sense for our project. But what we want to show today is the connectivity angle of this. So when we detect this scenario, what we want to do is let somebody know. Just send out a remote alert. Maybe this is alerting some mechanic or some shop that some service needs to be done on this vehicle the next time it's seen. Maybe somebody needs to be getting on the phone with its driver to talk through the problem and maybe how to alleviate it. But in any case, knowing that this problem has occurred is really, really important from a connectivity perspective and getting this information out there. So this is where the Blues note card comes into play. So what I've done is I've altered Owen's script for the note card, and there's actually only 2 chunks of code you need to make the magic happen here. So I'm going to scroll back up to the top because I've got 1 bit of code. Sorry for scrolling too much. I'll pause when I get there. The code that actually configures our note card itself is right here. So this is a bit of Python code. The note card's configuration is all JSON based, which makes configuration really, really simple. In this case, I'm running a request called hub.set. I'm setting this with a product. Now, this is a identifier that you can get from NoteHub, our cloud service that backs Note card that I'll show here in a second, and then a connectivity mode. The 2 main connectivity nodes for Note card are periodic and continuous. Typically, this is oversimplifying, but typically you use periodic if you're working off battery power or solar power and you're managing power and want to connect just occasionally. But in this case, in sort of a commercial vehicle scenario, you're going to be tapped into the car's battery or some sort of power source. So you might as well have a continuous connection so that data goes through as quickly as possible. So this is 1 bit of note card code. The second bit is back down by that check that we were at before. So we, again, detected the error leak here. What I'm going to do is run a second note card request called note.add. Note.add is the most common way of sending data with note card because typically you just give it a body with all of the data that you care about. So in this case, we have the prediction and the probability from the model, and then I'm dumping the data that we got from the OBD port that came from the CSV into here as well. So that's all in the system also. And then this last bit of code, this card transaction, is what actually sends data to the note card. And then from there, you kind of let the note card do its thing. So to run this script, I've got 2 samples up here, 2 ways to run the script, one with healthy data and one with leak data. So I'll run the healthy workflow first real quick, and you'll see what this would look like just running on a live device. This is kind of the boring version of this because this is just every half second taking in a reading from the CSV, and the model is just going to say this is healthy and okay. Now, again, Rob referred to this earlier, but there's some chance you might want to bring connectivity into this, like send some sort of status check periodically that says all systems green, everything's looking good. As we'll see in a minute, all cellular-based note cards have GPS modules on them as well. So maybe you want to use the note card for tracking your device at the same time that you're doing this sort of inferencing, and you want to send periodic location readings and with some status that everything looks healthy. But at the moment, we're not taking any actions from a connectivity perspective under the healthy scenario. We're just running through here saying everything looks good. Where this gets more interesting is when we look at the leak scenario, because that's going to hit our if check that's actually going to send data with our note card. So I'll kill that and run the playback that has the leak data. And what this is going to do is that if I pause on this line right here, it detects the leak and it queues that data up on our note card. That's where this total of 1 is coming from. That's the note card saying it's got 1 note or 1 data packet that it needs to send. And to show what that looks like, I'm going to switch windows over to NoteHub. So this is our cloud service that backs all note cards. And what I have is a project here. And in NoteHub, really your only setup, the only thing I did ahead of time is set up this project itself because I needed to grab from my settings this identifier. If you recall from earlier, down here in my code, I have a product that I set on my note card that maps to this. So this value over here maps to the value I set in my project. That's literally the full setup so that when my device connected, and my device just connected over cellular there, I didn't have to do anything related to the cellular connectivity itself. So the firmware I showed was the entirety of the note card code in that entire firmware sample. So you're not seeing things like communicating with a cellular modem. From a hardware perspective, I'm not dealing with a SIM card. I didn't have to sign up for a cellular plan. Kind of the magic of Blues is that you can take your firmware project, regardless of how it's written. So in this case, Python, but this could be to David's slides earlier. This we could have done this in Arduino. We could have done this on a full Linux system, and really anything in between. That's a great thing of working with Edge Impulse and Blues. We're pretty flexible when it comes to that sort of thing. So you didn't have to deal with any of that, and our data also came through as well. So these are our events that came through from NoteHub. It's listing the data that gets sent through. So I'm just going to go into this event so I can show you the full data sort of expanded out. This body, if you remember back to our firmware, this is the data from the OBD port, as well as our prediction and our probability. But the other cool thing is that Notecard includes a bunch of extra metadata to help you build sort of integrations and stuff around this data. So it captures a timestamp, but more importantly, it also captures locations as well. Now, my note card is indoors. Again, I'm not out driving a car. So I have a triangulated location. All note cards that have Wi-Fi built in, and I have a cell plus Wi-Fi note card that I'm using today, have the ability to triangulate a location using Wi-Fi triangulation. So that's what my note card is doing here. If my note card was outside and I did have a clear view of the sky, the GPS module would fire in and my readings would also be tagged with a GPS location. So what's really cool about that is that if you take this data and then go to use it, not only do you have the data here, just the raw data from your device, but you also have this metadata associated with it to help you track a location for where the vehicle's at, timestamps, and all those sorts of things as well. Now, the final piece of the equation is that as cool as it is that you can get your data over here into NoteHub, chances are this isn't the end-all be-all of where you want your data to live. You're probably capturing this data for a reason. Either you want to be sending this to your dashboarding system, or maybe you want to be sending it to your cloud to archive this data. Or in our case, maybe you want to send out an actual alert when this data comes through. So in NoteHub, we have this concept of routing, and routing is a way that you can use NoteHub to forward data as it comes into other platforms. Meaning, when that event came in, I could configure NoteHub to send it to my own HTTP endpoint, my own MQTT endpoint. I could send it to one of the big clouds. You'll see that there's a bunch of different options for common things you might want to do with your data as it comes in. So what I want to do today, you might have noticed if you're paying attention to the left menu, is to use Twilio, so a popular service for sending SMS messages, to send a quick message over SMS when this data comes in. So I've got the Twilio route configured over here. Really, all I'm doing is I'm saying all alerts that come in, I want to send out to Twilio, and I have a little bit of formatting for formatting up the actual text message I want to show. So a couple quick things before I show this off. First, I do have some auth tokens in here. I scrolled down on purpose because I don't want to leak Rob's Twilio auth token live on air, but you do need that to make this connection.
Too late. I'm already sending texts right now on it.
Yeah, I also have my phone number configured for this text in here, and I don't need that getting out either. So there's a little more configuration that I'm showing just to show that. But what's cool about this is a minor thing, but being able to do this formatting in NoteHub is kind of cool because it means I get to keep this logic out of my firmware. Chances are you don't want your firmware formatting strings or controlling exactly how this data gets up. It lets the firmware stay really, really simple. All it's doing is detecting the scenario and then just pumping the data out. And then from there, you let the cloud have that flexibility of where the data goes, how it goes, what it's formatted like, and whatnot as well. So I have this route disabled over here. So I'm going to enable it. And then I'm going to send this again. So go back in here. And I need to grab the air condition, the leak condition back over here and send it. And I need to kill the previous run and send this out. And so what should happen is if I go back to my events, you'll see that this data gets routed. And so what that means is if my phone mirroring is going to work correctly, what this should do, and yeah, there it is. I got to just drag. It is really hard to drag the iPhone mirroring. You can all judge the home screen of my phone here for a second. I had a message come in, and you'll see that I have this leak detected message come through, and it's got my data formatted up. And to just show you how quick that goes, I'll do one more round of this, with them both up. So we'll do this. We'll send this through. We'll send the leak. And the full workflow here is our data goes from our firmware up to NodeHub. NodeHub, because the route is configured, knows it has to fire off a Twilio route. And you can see then the text message gets sent out. And the key thing I want to stress here is that we're showing one specific workflow, but pretty much everything you see here is flexible. So we chose a Pi kind of for simplicity, but this could be any sort of edge computing device you want. This is Python. This could be C code. This could be whatever. And then in terms of data forwarding, I'm happening to show a text message, but you could send this off to any service that you wanted to. And that's one of my favorite things of working with these technologies. However, to wrap up, I got a segue to Rob here. The one limitation of what I'm doing is that I am using cellular. And if you're in a commercial truck, cellular is not necessarily a guarantee. At least in the US, I've been doing a lot of road tripping here in the last year or two, and there's a surprising amount of areas that still don't have cellular coverage. And NoteCard is quite powerful. If you queue up your data on NoteCard, it is smart enough to try again and make sure your data gets through. But if the information is urgent, you might need that data to go through immediately, even when you're off the cellular networks. And NoteCard isn't magic. It can't send data over cellular when cellular is not available. So, Rob, that is my very long-winded way of saying, what can we do about this situation when we don't have cellular?
What can we do? Well, thanks, TJ, for that intro. I'm going to introduce you all to Starnote for Skylo. So if you are not familiar with how Blues handles satellite connectivity, this is our product. So Starnote for Skylo is a $49 note card accessory being a keyword there. It does come in two variants that you see here on the left and right, and I'll explain those in a moment. First and foremost, as I mentioned, it is a note card accessory. This means that Starnote must be used alongside an existing cellular or Wi-Fi note card. It does not run on its own. That's because the Starnote was really designed around the idea of acting as a fallback or failover communication device, right? So you start with cellular, for instance, and then you fall back on satellite if you lose connectivity. You can use it as a primary radio, but it still needs a paired note card to function. And as we'll talk about, there's serious data limitations, especially related around cost for satellite data. You don't program Starnote directly either. It's another nice thing about working with Starnote is that since it works with a paired note card, you actually program the note card, and then the note card decides when and how to use satellite connectivity based on your requirements. Now, thanks to our partner Skylo, Starnote uses geostationary satellites. So you're not waiting for a satellite to move into view. You actually use the supplied LTE antennas that we provide to communicate with the satellites, which is kind of mind-blowing. Starnote does ship prepaid with 18 kilobytes of data. I know that doesn't sound like much, and it's not, but it actually is enough to send one 50-byte payload per day for about a year. You can pay to go beyond those 18 kilobytes at a rate of 75 cents per KB. Now, to put the pricing that I just described into some kind of perspective, any of you familiar with Blues know that part of the reason we got into cellular in the beginning was because of the insane pricing models. Satellite is no different, if not worse. But today with satellite, you either kind of get nicked on monthly minimums or very high rates per kilobyte. An important feature of Starnote and Blues is that we're not enforcing monthly minimums. And again, we do bundle in that 18 kilobytes of data to get you started. Now, as mentioned at the beginning, there are two Starnote variants. They only differ in their antennas and their size. The one on the left uses onboard antennas provided by Ignion, and we also have one with the UFL connectors for attaching a Skylo certified flexible antenna. Now, at a very high level, this kind of lays out the outbound and inbound paths of data from NoteCard to Starnote to those geostationary satellites via the Skylo network onto NodeHub and then onto your cloud endpoint. And as complicated as this might even look, truth be told, you only need to care about what I'm highlighting here. Blues and Skylo really eliminate all the complexity of satellite connectivity, so you can really focus on your product design and, again, leaving all this hard connectivity stuff for us to handle. So that's Starnote at a glance, and I did want to really briefly touch on how to get started incorporating the hardware as well. So let me first introduce you to Note Carrier XS. This is a specially designed note carrier board, development board, however you want to frame it, for use with Starnote. It does feature both quick and eSLAV connectors for attaching peripherals. It does, of course, work with either Starnote variant, and it does have a USB-C port. So it's a very simple setup. Just slot in your Starnote and either a cellular or a Wi-Fi or a Cell plus Wi-Fi note card in, and you are good to go hardware-wise. Now, this is a bit of information overload, but I just wanted to be clear that you can use a Starnote with a Pi. So what TJ showed off, what Owen showed off, we can absolutely integrate the note carrier into it. What you see here is literally next to me on my desk, actually, and what I'll be using for my demo in a moment. The trick with using Pi with a note card and Starnote is that you have to use the aux UART provided on all new-ish note carriers. Since note card to Starnote communications happen over the main UART. So that's just some of the complexity involved here, but easy enough to wire it up. Now, when writing firmware to work with Starnote, again, it's important to remember that the Starnote only works with a paired note card. So you are programming the note card to decide when and how to use Starnote. That starts with something called NTN mode, which stands for non-terrestrial networking. So NTN is, if you don't know, it's the 3GPP standard for satellite-based interaction with cellular networks, of course, as provided by Skylo. So when communicating with the Skylo network, Starnote actually uses non-IP data delivery, which is kind of interesting. It's a message-based transmission protocol where all the data that's transmitted only contains app-related info, and then that transmission only happens, it only lasts as long as it takes to send that data. So compared to IP-based messaging, which we're all probably more used to, it's really like the difference between sending a text message and a phone call, so much less bandwidth. You can also tell the note card to only communicate in NTN mode, so only use satellite, or more likely you're going to tell it to, again, as these commands go down, start on Wi-Fi, fall back on NTN, start on cell, fall back at NTN, or go Wi-Fi to cell to NTN. So there's a lot of flexibility in there. Now, when pairing a Starnote with a cellular or Wi-Fi note card, you're also likely not going to be sending the same events over cellular and satellite. So what TJ showed off was a pretty straightforward, like, we're going to sync some data to the cloud. Realistically, if you fall back on satellite, you're going to only want to send a subset or maybe unique alerts, whatever it may be, over satellite. You're going to use some commands, and I'm not going to get into the details here, but there's a note.template request that we provide that allows you to say, I only want to send this data over cellular. So this is a larger, you can look at the body here, that's kind of a larger payload. Whereas on satellite, we're going to condense that payload down. There's a lot that's going to happen on the note card that's going to compress the packet size down as small as possible to make sure that you were not using too much of your data allocation. Now, lastly, coverage is always a big deal, of course. So Skylo publishes a full coverage map at skylo.tech. If I can quickly summarize, you're going to get full coverage literally anywhere in the US, Canada, the Caribbean, was it Brazil, Europe, Australia, New Zealand. I think I hit them all. Large chunks of blue ocean as well. Coverage in Japan is coming soon as well from Skylo, but you'll have to check the Skylo coverage map just to validate that. So finally, quickly in summary here before the demo, Starnote, again, I'm going to quiz you on this later. It is a note card accessory designed for failover. It does ship prepaid, $49, 18 kilobytes of data. We can bill you later for additional data. Again, two variants, the UFL and the onboard antennas. And the easiest way to get started is really by using the Note Carrier XS. We do have a separate Starnote starter kit as well that's available. Includes a Starnote, a Note Carrier, and a Note Card Wi-Fi. So it's really easy to get started. And again, check out those coverage maps at skylo.tech. Oh, and if you want to see Starnote in action, I actually wrote up something on Hackster. I guess it was last year even I did this, hard to believe. But if you just search for Starnote on Hackster, you'll find it. It provides a pretty accessible intro to Starnote as well. So with that intro, let's see if we can't get satellite connectivity working from my desk. And
This is the moment where I'll cross my fingers, but while you're doing that, Rob, I'll go look for that link and drop it into chat for the folks.
Yeah, so the way I have things configured here, I actually I'm using a Skylo certified antenna out in my window with some massive cabling to reduce the signal loss. And oh, there's my browser window. And so what you're seeing here is we didn't have a chance to show this in TJ's section, but this is the in-browser REPL that we provide. So it's a terminal interface to my note card. I'm currently connected to my note card directly, and note card has a paired Starnote sitting next to it. So this is kind of the from scratch demo of using Starnote with note card. And the first request I'm gonna send is that hub.set request. And let me blow this up a little bit. TJ showed this earlier. Effectively, what I'm saying is I'm just telling the note card which Note Hub project I want to link it to. I'm doing something a little bit different here than TJ. I'm setting the mode to minimum. So it's not continuous mode. It's not periodic mode. It's minimum, which means I only want you to connect to Note Hub, connect to the cloud when I literally tell you to do it. So don't do anything else. Next, I'm going to send a note.template request. Again, note.template, it's a hint effectively that's shared between Note Card and Note Hub, so that Note Hub knows when I send data that's in this sat.qo note or this event format, I'm only going to be sending temperature and humidity data. This allows us to dramatically compress data used over the wire or over satellite in our case. Now, anytime you add or create a new template, it's important to know that that needs to be synced over a non-NTN protocol. So in my case, this is going to be cellular. And what we're going to do is we need to wait for this connection to be established with Note Hub. And in fact, I'm going to do a little enable trace mode here so we can actually see what's going on. And we should see in the status bar here, it's going to initiate a connection. It started with Wi-Fi because I'm using a cell plus Wi-Fi note card, so it's always going to try Wi-Fi first, and that's going to fall back on cellular. And I'm not sure why I'm not getting any trace log information here, but of course it wouldn't be a proper demo without something not working. But we're seeing in the status bar here, like we're connecting over TLS. This is, again, just going to sync some data, the template data and some between Note Card and Note Hub. In fact, let me pop over to my Note Hub project here. Again, blow this up a little bit. And I'm going to reload, and we should see, sure enough. So you can see the device connected. So the devices are in sync. Now that we know that they're in sync, I'm going to do something that you should never do in production. And that is to force NTN mode, meaning I'm telling the note card, no matter what you do from here on out, it's got to be done over satellite. And we're going to run another command that's called ntn.status. This is going to confirm that the satellite module, Starnote module, is idle. It's connected, but it's just idle. So this is all good so far. Now I want to create an event or a note using the note.add API. And again, only temperature and humidity data. We're keeping this very simple. Now you'll notice that when I added that note, nothing happened here. The note card didn't start syncing data with the cloud arbitrarily, right? That's because, again, we set it into minimum mode, meaning don't do anything. Just save it on the note card until I tell you to. This is a really great feature because regardless of the radio you're using, there's often times where you're going to want to only occasionally sync data, and you can store, there's like between 1 and 1.5 megs of flash on the note card that's user accessible. So you can store a lot of data on the note card before you start syncing. I'm going to try enabling trace a different way just to see if we can make sure we get this. Now, sorry, we get the trace log going here. So now that I've stored this data on the note card, the last thing I need to do is to initiate another hub.sync request. And this time you'll see, it did that because my cat literally jumped on my desk. So you notice that the accelerometer detected the bump on the desk. So thanks, cat. You notice this time with the hub.sync request, I'm adding the out true argument. This tells the note card only do an outbound sync of data. So don't worry about anything inbound from the cloud, only sync outbound data. Now we get to watch as the note card switches over to satellite, and we'll cross our fingers that this all works. A few things I'm going to try and point out here as this scrolls by is you can see, I saw somewhere up here where it said switching from modem. Oh, you're switching from modem to NTN, so that's good. So it's switching from cellular to use the satellite. We're going to now have to wait for the satellite module to find to find the satellites in the sky, and it looks like it already had GPS. The
Yeah,
GPS coordinates logged earlier.
the time is behind. Isn't that also sent from the satellite?
In our case, it should have been sent. It should have been synced up when it connected over cellular. I think
Oh,
-1
right,
seconds
from the
is not a
cellular.
big
Yeah,
deal.
yeah.
Shouldn't be a problem. But yeah, when using satellite connectivity, you absolutely need an accurate location of your device so that it knows exactly where to look in the sky for um, for the satellites themselves. And in fact, it looks like it finished here. And so what we can see here, this line is important. So it queued up an 11 byte note. So what I sent that I'm just going to paste this in here. This body element here, with compression and everything, that ended up only being 11 bytes of data. Now, if I head over to Node Hub here and actually head to the Events tab, we can see, sure enough, that this was transported over satellite. So there's nothing up my sleeves here, and that's our data as well. So this is not like the sexiest, mind-blowing demo that we've ever seen, right? But in a way, it kind of is, because just like sitting next to me on my desk, I literally sent data from my product here up to the cloud using satellite connectivity. Now you can think
You sent
about
it beyond the
extending.
clouds. You sent it to space.
Yeah, it's in
Yeah.
space. And I'm not convinced there isn't something up your sleeves. Let me see those sleeves. There might be a satellite in there.
Yeah, the clouds are basically terrestrial, man. This is not terrestrial.
That's true. That's true.
Yeah.
So
Yeah, this is really cool because this is what we wanted to explore for edge. You know, the true edge case is space, and we've never really gotten to
Right.
cover that. Like, so
Well,
it's
we
really
did today.
Yeah.
So really, like, yeah, the last thing I want to mention is that I know it's not in the code that TJ showed off, but really to add satellite connectivity, it's trivial. It's a handful of commands that you would be adding to what TJ's done. It could be done literally in like 5 or 10 minutes. So I don't know. I think we're making satellite connectivity much easier to implement and everything. And I only have one more slide here, so I can.
Oh, also, there's a Hyundai satellite from 1998, which you definitely has an OBD port, so we could get OBD data from.
Nice. The last slide I want to show here, of course, just for getting started, get started with EdgeImpulse Studio at studio.edgeimpulse.com. If you want to try out satellite connectivity, we do have, again, that aforementioned starter kit at shop.blues.com. With that, how are we doing on time? It's exactly top of the hour. All right. I'm not going to spend any more time on this. I'm just so you know, we will get a follow-up email with a link to the recording and some other resources probably on Monday. Thanks, David. Thanks, Owen and TJ.
Yeah, no worries. Well,
There's a lot of content here.
I think we got most of the questions answered
Okay, good.
as we went along. We were all kind of monitoring the chat there while you were going through the demo, Rob. So I think we got them all.
Yeah,
Perfect.
if we did miss any, both Edge Impulse and Blues have forums that you can reach out to. Is probably the best way of asking
Certainly.
questions, or reach out to us via email is another good way as well. We'd be happy to follow up.
Email, LinkedIn, any normal channel, and we'll get a question answered for you. Not a problem at all.
I should have just linked
Probably
my phone
best.
number, and then people
Yeah,
could
your
have
phone number is
they
already
could have
in
just
the
called
chat.
me up right after this.
Yeah, all they do is play back the recording.
Probably in there, actually.
Yeah.
All good, but it was great as always. Thank you, Rob and TJ, for hosting and putting it on. This was an interesting topic. I can't believe that the demos worked. That's a
It's always good. Next time we're
doesn't
gonna have
always-
Owen on
that
the.
doesn't
We're gonna
always
have
happen.
Owen driving around. Owen's gonna be driving around. We'll live stream the whole thing. That's our next goal.
Oh.
I've already got a couple of engine lights and error codes to clear on my car. I left it running out there actually there's recordings of capturing the data as well, and all the scripts and everything are there in the
behind the
tutorial doc.
scenes, a behind the scenes take. So, all right.
Thanks, yeah.
Well, we're good from our side.
Great. Yep.
Yeah.
Thanks everyone
Thanks
for
everybody
attending.
again.
All right.
Thanks for having us.
Bye.
Bye
Thanks.
all.
Bye.